You remind me of this, we're finishing. So starting with 7C, if you did this on your calculator or Desmos, that's fine, you don't need that work. If you did the work, it should match mine similarly. And your X-intercept was 6, 0. So you should have set your equation equal to 0 because you're looking for a 0, which is your X-intercept. So your y has to be 0. Subtract 4 on both sides. If you are dividing by fractions, that's the same thing as multiplying by the reciprocal, which is what this is doing. And if you put negative 4 times negative 3 over 2 in your calculator, you get positive 6. Number 2 gave you a graph. It asks you to find the solution. Remember, solution is another word for X-intercept. So you had to find your X-intercept of this line, and that was at negative 2, 0. Number 3, it asks for the roots. Roots are another word for X-intercepts. You could have found that on your calculator or Desmos. I think that's what I told you to do. So if you looked on your calculator or Desmos, one of your intercepts was a decimal or a fraction. So negative 1.50 or negative 3 over 2, 0. And then the 2, 0 was your other one. If you have a question, please raise your hand. Yes, Taylor.
If you were using a calculator, how would you compare the because I got the 2, but I didn't get
When we get to our factoring unit, that will make sense. That's why I said use Desmos or your calculator. Number 5 was a little bit challenging, so I'm going to talk through all of this. The question was asking what number could we put in for k so that we get the same X-intercept for both of these problems. So to find what would be the same X-intercept, you would need to find your X-intercept of this one, which is what this part is, finding the X-intercept. That X-intercept happens to be 6, but then that doesn't answer the question, what value of k do we need to put in for the X-intercept to also be 6? So because our X-intercept is 6, 0, we can put that ordered pair into the second equation, which is what this middle part is. Putting in 0 for y, 6 for x, and solving for k. When you solve for k, you get negative 18, which is the answer they're looking for. The last part in blue is just making sure that works, going back and checking. So if we put negative 18 back in this equation and solve it for an X-intercept, we get that 6. So they both have the same X-intercepts, but our answer that we were looking for is k equals negative 18. Questions on any of the ones on this page before we go on to the next? Yes, Michaela.
How would you find number 3 on the calculator?
Number 3. So I'm going to be honest and say I use Desmos, but if you use,
how do you know what this
you would just
Oh,
type
could you
that
say
in.
that for a second? I'm talking down.
You would just type that into Desmos, click on the graph, and your intercepts will pop up.
Oh, so you have to find it from the graph.
If you were putting it in your calculator, the 2, 0 is easy to see. The negative 1.5 to see what the decimal would be, you would have to use the steps we found in the on the notes, the left bound, right bound, those things.
Could you scroll down?
On the next page, if you put these in your calculator or Desmos or solve some of them, these three would have been the ones that had an x-intercept of 3. Number 2, I told you to skip. Number 3, you could have put that in your calculator, Desmos, or solved it as I did. But that one you needed to find both your x and your y intercepts. So to find your x-intercept, put 0 in for y and solve. That x-intercept would have been 4 over 3, 0. Leave that as a fraction because it would have repeating decimals. Leave it as a fraction because it has repeating decimals. So unless it has a nice decimal like 0.25, 0.5, I'd say up to like 3 decimals. If it has up to 3 decimals, then you can put it as a decimal. If it has repeating decimals, leave it as a fraction. And then your y-intercept you didn't really need to solve for because it was in this format, the same format that we solved all the previous equations. So if you looked at the number without a variable, that would be your y-intercept. Number 4 gave you a graph and it asked you to find the y-intercept. So that would be at 0, 4. Yes, Michaela?
What's the final answer?
4 thirds 0 and 0 negative 4.
So 2 answers?
You have to find your x and your y-intercept. Yeah. For number 5, you could have graphed these. Most of these you needed to graph in Desmos for your calculator. It's asking which of these have only one x-intercept, so that means it needed to touch or cross the x-axis one time. If it touched it more than once, that was not your answer. If it did not touch your x-axis at all, that would not also be an answer. So these 2 were your answers. Questions on any of those? Priscilla. I didn't hear anything you just said.
On number 1, I did that one on decimals, and I didn't get like the
On this page?
Yeah.
You didn't get this one?
Yeah, I did.
Read that one off to me again.
-3. Oh wait.
Never mind. You're gonna get in the negative. Okay. Alright. There was one last thing that I wanted to show you guys before class ended, but then we ran out of time on intercepts, so we're going to talk about that and then move on to slope. You can either do this on your intercepts page or somewhere where you have space. It doesn't matter. This is really to help you with some things you may see on the test, and it might be in this format, but also one of the Khan Academies, a lot of the questions are written in this format. So somewhere where you have space, I want you to write down this equation. process to solve this is the same. You're still putting 0 in for x when solving y and putting 0 in for y when solving x. It just looks different. So for finding our x-intercept, we need to put 0 in for y. So do that. And then we could solve for x. This would just become 0, which really means I'm just left with 3x equals 18. And I could divide both sides by 3 to get an answer of 60. I could do the same thing to find my y-intercept, but now I'm going to put 0 in for y. I think I said put 0 in for y, but I meant x. And solve for y. Because we put 0 in for x, we can really just put 9y equals 18 and solve from there by dividing both sides by 9. To get the order to 0, 2. So if you get something in this format, that would be how you go about solving that. There is like a shortcut when doing this. When you get this equation, if you remember that for x-intercepts, you're putting 0 in for y, and for y-intercepts, you're putting 0 in for x, you could kind of mentally put 0 in for x or for y, know that that's going to become 0 and disappear, and skip to this step. So if I was solving for my x-intercept, I could look at this, skip to this step, and then solve. And then I could do the same thing for my y-intercept, know that I'm solving for y, this would disappear, and skip to this step, and solve. So there.
From the equation at the top, can't you just put that into y equals mx plus b form and then just figure it out from there? You don't even need to do any equations for that.
So for this one, we're looking for the x and y-intercept. So doing that will cause you more work.
Oh, okay, so this is really the easier way.
Yeah. So if you were to convert it, which some of you may know how to do, some of you may not, that would really only tell you your y-intercept for sure, but then you would still have to solve for x's, then you would be solving twice. I mean, you still really are, but it would be an additional step. Any questions on this process? We're now switching gears and we're moving on to slopes. So you should have the slope notes in front of you. Like I said when we started intercepts, some of this will be familiar to you, some of it will be new to you. If you were using your computer, you can close that for right now. You don't need that. So the first page has a lot of vocab, so I'll let you write and I'll talk through them. Ready. So for this, Michaela, give me 1 second. Let me read through this and then I'll answer your question. For the rate of change, it says a ratio that shows how one variable changes with respect to another. On a linear graph, this is called the slope of the lines. So rate of change, slope, those are interchangeable words. Slope is written as a ratio of the vertical change, the rise, over the horizontal change, the run, between any 2 points on a line. This remains constant for any 2 points on the same line. So whatever the slope is between point A and point B is the same between point B and point C and point D, and so on and so forth. Slope is written as a fraction in simplest form. So ratios come in different variations, but our ratios for slope are going to be in fraction form and simplest fraction form, unless it's like a whole number. So simplest form could also just be a whole number. The variable for slope is m. Michaela, what was your question?
Oh, what's the topic?
Slope.
True slope.
So we're going to be finding slope in 2 different ways. One is going to be from a graph, or graphically. The other is going to be algebraically from 2 points. So
Can I use question?
okay, we'll get that. Anyone still need those before I move down? Sorry. There are 4 different types of slope. So you guys don't have these, but make like X and Y axis graphs in these boxes. And you can write these 4 slopes. Positive, negative, 0, and undefined. So I'm going to draw like makeshift graphs on these. You can do the same. So for a positive slope, it's going to look something like this. There are positive and negative directions. If you go up or you go right, those are both positive directions. If you go down or you go left, those are negative directions. So as I'm looking at this, if I go left, if I'm reading this left to right, I always need to go up or down first because it's rise over run. So I would go up and then right. And that would give me a positive slope. If I was looking at this right to left, I would need to go down and then left. Down is a negative, left is a negative. 2 negatives make positive. So either way, you would still get a positive slope. Your negative would be the opposite. So if I'm looking at this right, left to right, I would need to go down and then right. If I'm looking at it right to left, I would need to go up and then left. So when you go negative, or when you have a negative slope, only one of your directions is negative, not both, because that would make it a positive. For your zero slope, that's going to be a straight horizontal line. Wow. Or as straight as humanly possible. Where you don't have a vertical change at all, but you do have a horizontal change. So that would be like me walking across this room would have a zero slope. When you ride the bus to school, that would have a zero slope. Driving in your parents' car, or when you start driving, that would have a zero slope. Undefined slope will be a straight vertical line where you have a vertical change, but you don't have a horizontal change. In your calculators, pick whatever number you want and then divide by 0. What happens?
0.
It's not 0. You get an error. We cannot divide by 0, which is why this is undefined. Questions on your types of slope? In this box up to the side, write m equals rise over run. So we will always go up or down first, then left or right. Think about when you get out of bed, you usually sit up before you get out of bed. For most of us.
I roll out of bed.
I say for most of us.
Yeah. I just keep laying there. It's not just out.
That's the thing you don't do.
Or somebody else pours water on me.
So we're going to do some examples of slope from a graph, starting with these 4. Some of these graphs will have points on the graph. Some of them will not, and you'll need to find points that cross the grid line in the background exactly in the corners. If you did not see these points, this one has these 2 points right here. So it does not matter which point you start at, as long as you remember rise comes first and then run. So if we're looking at this left to right, I'm going to count how many units I go up. And then how many units from that point I need to get over. So if I have 7 up and 4 to the right, up and right are both positive directions, so your slope would be a positive 7/4. But if we went the other way, so let's say we started at the top, so now we're looking at it right to left. I cannot go up in this, so I would have to come down. And then I would have to go left. So that would be a -7 over a -4, which would still give me the positive 7/4. So you can do it either way. It's just your preference.
Congratulations, you created a rectangle.
I did. And 2 triangles. Any questions on that one, Peyton?
If you were to like, get like a number, like a fraction, we could simplify it by using it.
Yes, always. Right, for number 2, we're going to do the same thing. if you did not see it, there are these 2 points drawn in. If I'm going left to right, this would be down 3, and to the right, 3, 4, 5, 6, 9. So the down would give me a -3. And then I could simplify this to be what? -1/3. So you could keep the negative in your numerator or put it out to the front. I would not keep it in your denominator just because you won't see it like that. But because we simplified it, this means that there should be another point every time I go down 1 to the right 3. So to test that theory, I'm going to start back at the top. If I go down 1 and to the right 3, there's another point that crosses those grid lines exactly. If I go down 1 to the right 3, there's another point that crosses those grid lines exactly. And that pattern would continue all the way across the line because it would continue on forever and ever. If you were looking the other way, let's say I found these 2 points first and I did not see the other 2, that would still be fine because you would still get the same answer. But I would go up 1 and to the left 3. Which would still give me that -1/3. Questions on number 2? Before we do 3 and 4, I want you to write this off to the side. Hoyvux. Hoyvux. Vuxhoy. This will help you remember which ones have 0 slope, which ones have undefined slope. When we get into graphing, it'll help you determine which ones are horizontal and vertical or x = y. So this is for horizontal lines. So left and right. Horizontal lines have 0 slope. And these are usually a y = equation. Again, that part will make more sense later. And then these are vertical lines. So up and down. Vertical lines have undefined slope. Or you can just put U in D. And these are usually x = equations. So anytime you see a horizontal or vertical line, think in your mind, Hoyvux. Does this have a 0 or undefined slope? Yes.
On the test, we're going to be in the vertical line ones that are y.
Vertical lines are always x =. So for number 3, if you see that this is a horizontal line, what type of slope will it have? 0. Get in the habit of putting m equals for your slope, and then you can put 0. You could still do the work we were doing before. This does not go up or down at all, but this does move left to right. So there are 2 points right here. I see that it's moving 4. But 0 divided by anything is 0. That's when you're dividing by 0. Okay. And then number 4, if you see that this is a vertical line, what type of slope will it have?
Undefined.
Undefined. If you wanted to still do the work, like the counting work, I do see that this goes up and down. There are 2 points on here. And I'll say this goes down 5. But it does not move left or right at all. And anytime we divide by 0, we get what slope? Undefined.
So on the test, do you still want
Hands,
us to solve?
please, if you have a question. CK.
On the test, do you still want us to solve like that, or can we just say it's undefined?
You can just say it's undefined. I was just showing if you did want to still solve it like that. Okay. On the next page are a bunch of graphs that I want you to find the slopes for as many as you can in the next 6-ish minutes. And then we'll go over however many you got done. So in the next 6-ish minutes, get as many of those slopes done as possible.
I have it agree and I don't need, my mom's like a teaching lesson, so I don't need a teaching lesson. Like my mom was in private school, she taught, so.
Okay, so I'm going to read off the slope. Just make sure yours match. If you have any questions, mark that one. We'll come back to it after I read off all of them. So number 5 should be -3. Make sure you're putting m equals whatever the slope is. 6 was 4 over 5. 7 was 0. 8 was +2. 9 was 1/3. 10 was undefined. 11 was 4. 12 was 2/3. 13 was -5. 14 was 1/4. 15 was +2. 16 was -2. I'm sorry, that's a 1. -1. 17 was -3/4.
What?
Hold on. 18 was -1/2. And 19 was 5 over 2, 5 halves. Okay, if you had a question, you can raise your hand. I'm going to for which number? I'm sorry. 14. Yes. Positive 1/4. So if you're going up and right, this should be positive. Did we have other questions? Say that one more time. Ladies in the back, please stop talking.
Number 17 is 4, 4, 7, 3, 2, 7.
So I was saying don't put the negative in the denominator because you won't see it like that. You can put it like this or put it out to the front. Either of these. Okay?
When we like write answer the test, like will you accept it, like put -3
You need to simplify all answers. Yes. On the answer. With the what? Say that one more time.
For 16, the rise or the
That depends on how you looked at it. At the end, you need to simplify, so it'll be -1 no matter what. Other questions on those? Move on to the next page. And write this formula in this box. M equals y, it's like a sub 2 or a subset of 2. Y2 minus y1 equal, or I'm sorry, not equals, all over x2 minus x1.
I hated this so much.
So when we do this, this is like what your graph is doing when the points are plotted, when we find our rise over run, but now we're actually doing it algebraically. You need to know this formula. There are things you can switch in this formula that would still make it okay though. If you forget the order, and let's say you put y1 first, and then subtract y2, as long as you also switch these two, that's fine. You could do either of those two. What you cannot do is switch your x's and y's, because y's are your rise, x's are your run. Your x's have to stay in your denominator, y's have to stay in your numerator. What you also cannot do is switch one of them, like switch y1 and y2, but not switch x1 and x2. Because what will happen is you'll get a positive where it's supposed to be negative, or vice versa. For this, always simplify just like in your graphs. When we get these, I always label them, that way I know which one is which. So in number 1, these are the order pairs xy, xy. So the first one I just label x1, y1, and then the second one x2, y2. After you have them labeled, you're just putting it into the formula. Lily, make sure you're writing this. So y2 would be 3. We're always subtracting no matter what. And then y1 would be 1 over x2 would be 4. We're always subtracting no matter what. And then our x1 would be 1. You would subtract your numerator and then your denominator and simplify if necessary. 3 minus 1 would give us 2. 4 minus 1 would give us 3. 2 over 3 cannot be simplified, so that would be our slope. To show you that the other method works, like when you switch y1 and x1, I'm sorry, y1, y2, x1, and x2, I'm going to do the same thing, but then it would be y, you don't have to write this part, you can if you want, y minus 3 over, I said y, I meant 1, 1 minus 4, so I'm switching both of them if I forget the order. 1 minus 3 would give me negative 2. 1 minus 4 would give me negative 3, and that would still give me positive 2/3. That's why switching both of them works. Excuse me, if I only switch one of them, I would end up with a negative somewhere, and the whole thing would be negative, or a positive somewhere, and again, the whole thing would be negative. Do we have questions on that one?
Not into the question, but if you're subtracting a negative and you have a negative behind that subtraction, it would just be another thing to add.
Yes, you would add. It would become a plus. So in number 2, we're actually going to see that. So number 2, same thing, label them. x1, y1, x2, y2. And this would give us -2 minus 4 over 10 minus, because we're always subtracting, and then our negative. If you have, that's not sharpening, Savannah. You need to sharpen it.
Oh, I have to sharpen it. I was going to use a hand sharpener, so it wasn't mine.
If you have a negative and a minus, those come together make a plus. It's still like the two negatives make a positive thing. So in this instance only, you could change this to be a plus. But I would not start putting pluses in just because you have positive numbers. The only time that changes to a plus is if you have a negative and a minus. So this would give us -6 over +12, and we could simplify that to be what? -1. For sure, there are 3 more that I want to do. I don't know if we'll have time to do all 3, so we'll see how far we get with those. We're going to skip down to number 5 and do the same process. Label them x1, y1, x2, y2, and then put them into your formula. 9 minus 9 over 3 minus 5. Nine minus 9 would give you 0. 3 minus 5 would give you -2. 0 divided by anything would give you 0. If you divide by 0, you get undefined. So if we look back at the ordered pairs, these have the same y value. If you notice that as you get ordered pairs, if you have the same y value, then you will always have a 0 slope. So you would need to know that those 2 points are going to fall on the same line, on the same horizontal line, so you would have a 0 slope. For number 6, do the same process. So we would have 5 minus 8 over -7 minus a -7. Five minus 8 would give you -3. -7 minus a -7 would be the same thing as -7 plus 7. 0. So that would be 0. Anything divided by 0 would give you undefined. If you look back at the ordered pairs, here we had x values that were the same. So if you see that your x values are the same, these 2 points are going to fall on the same vertical line, so this would have an undefined slope. Yes. Yes. You just have to know which is which. We're going to start this last problem and see if we have time to finish it. This last one is, it's the same process, but you're dealing with fractions. So it takes a little longer because there's a lot more work.
Is there already a question they put on the test?
With the fractions? Yes, that's why we're doing it. I would say find somewhere where you have space. You may have to get a separate sheet of paper because it takes up a lot of space.
Say that one more test so we can break it down.
I would say if all of the fractions are nice fractions, then sure. But most of them will not be. Okay.
Can we use a calculator?
Yes. So we're going to do it all by hand first, and then I would show you how to put it in a calculator.
Oh, we'll be able to use the calculator on the test, right?
So we're going to do number 7. So again, somewhere where you have space, you may have to put it in this example space, but turn your paper to the side. Wherever you have space, you may have space in that box, I'm not sure. So we're going to start this the same way we would any other problem. This would give us 3/4 minus 2/5. All of this is going to be over 1/3 minus 2/3. What? Almost. So if you switch these two, you need to switch these. Okay, so we're going to do this first, all by hand, and then we'll go back and I'll show you how to put everything in your calculator. So if we were doing this all by hand, focus on one part and then the next. That way you don't mess things up. Think about your fraction rules. In order to combine fractions, you have to have the same denominator. Our denominator fractions have that, but we're going to focus on our numerator fractions for a moment. So we need to get these to have the same common denominator, so if they have a common multiple, if that's what we're going to answer, 20 would be a good answer. So to get these to be 20, I would need to multiply this 5 by 4. Whatever I do to one part of the fraction, I have to do to the other. And then to get 4 to be 20, I would multiply that by 5. Whatever I do to one part of the fraction, I have to do to the other. So that would give me 15 over 20 minus 8 over 20. And my denominator fractions would stay the same. We will in 1 second. So then we are combining the fractions. Remember, you're only adding or subtracting your numerators together. So 15 minus 8 would give us 7 over 20. 1 minus 2 would give us negative 1 over 3. We have fractions within fractions, and that looks a mess. So to fix that, anytime we are dividing by a fraction, we are multiplying by the reciprocal. So we're going to take the denominator, flip it, and multiply that part. What we do to one part of the fraction, we have to do to the other. So we're also going to multiply the numerator by that same flipped fraction. Raise your hand if you have a question. It's the same process, it's just with fractions. So you take this and flip it. So what would happen here is that these cancel and become 1. And then multiply these across. 7 times -3 would give you -21. 20 times 1 would give you positive 20. Anything over 1 would just be whatever else it was. So -21 over 20 would be the final answer. Yes, Felix.
Maybe -1
I want to be 2 days.
If you have a comment or question, please raise your hand.
Do you know how many is there gonna be a specific place in the test for these questions?
So slope is 1 section. I cannot say for certain how many of these questions, but I will say probably no more than 2 or 3. Bella? Doesn't have to. I could have kept it in the bottom. It would just be easier for me to keep it. Okay. Now I'm going to show you how you would do all of that in your calculator, and then I'll let you grab your phones. If you were doing this in your calculator, I would still need to see the setup of the original piece of this, so I would need to see this part right here. I would need to see that if you do the rest of this in your calculator. Only that part, if you do everything in your calculator. Once I have everyone's attention again, I'll do this in the calculator. Really, faces left. So you could do all of your subtraction fractions in your calculator. Alpha y equals, I forgot what one of them was. Alpha y equals 3/4 minus 2/5. Alpha y equals, your home screen, second mode. So that would give us the 7/20 that we got. I'm going to put in the bottom fractions just because I'm doing this on my calculator. So negative, I'm sorry, it wasn't negative, it was just 1. 1/3 minus 2/3 give us negative 1/3. Then I could go back up so that that's highlighted, hit enter, hit the division, go back and grab my other one, hit enter, and then hit enter again. If you have a question, raise your hand. And then you put in your equation, 1 or enter. Peyton.
Do we have to show our work on the test? Or can we just use the calculator?
So, like I said, if you show your work, you have to show me how you set it up.
Okay, that's it. Okay, later.
And that's for all questions, not just a fraction question. If you do it like this, that would probably be easier than the way I'm going to show you. You could find those and set it up like this. I would not advise this, but some of you may forget that part and do this anyway. If you got your 2 fractions and then wanted to put them all in one, you would do alpha y equals, go up to the top part, do it again, go down to the bottom part, do it again, and put both fractions in. You would still get the same thing, but you have to remember where you're putting things. Okay? That is all we're doing today. You guys can put your calculators out and grab your top.